So, after looking at these and you guys have found the patterns, let's give it names. Okay, so we're just looking at each of these patterns right here, these sequences, and we found something they all have in common. If you want to go from one number to the next, you just have to multiply by a certain number. In this one, we multiply by 2. That is your common ratio. And this one right here, when you're multiplying by each of these, your common ratio here is 3. But what if we don't see that? What if we can't figure it out? Second term divided by the first. Third term divided by the second. That's how you would find it. It even works with fractions. Second term divided by the first.
What if they don't give you the what if they give you only the first and fifth term?
We could talk about that when we get there. Okay, and we will get there. Okay, so yeah, this one would be negative right here because you see how the sign is switching every time? It's negative, positive, negative, positive. So how would you write an nth term for this? Now, I can show you guys how we find the nth term by writing a bunch of stuff, which is what I'm going to do. So I have a sub 1, which is 2, a sub 2, which is 4, and a sub 3, which is 8, and a sub 4, which is 16. Okay, that one's pretty much as simple as we can get. How else can we get 4? Huh? We have 2 times 2. Okay, then how else can we get 8? 4 times 2. And how else can we get 16? 8 times 2. But is there a different way we can write 4? 2 times 2, right? 2 times 2 times 2. And then the last one, 8. I can write that as 2 times 2 times 2 times 2. Actually, I should write these as 2's. Okay, I wanted you guys to see this guy, this guy, this guy, and this guy. How they're all the same right there. And what starts happening? We have this ratio right here multiplying to the 2 multiple times. There's another way we can write these ones. Do you guys know how we can write this one? 2 raised to the third power. This one would be 2 raised to the second power because there's 1, 2. This one has 1, 2, 3. Okay, the next one, it would be 2 times 2 raised to the first power. And if we keep following our pattern, this would be 2 times 2 raised to the 0. Do you guys see a pattern? 3, 2, 1, 0. Okay, now, this is what you guys have to recognize. What's the relationship between that 1 and that 0? This 2 and this 1. This 3 and that 2. And this 4 and that 3. What's the relationship? It's 1 less. 1 less. And so that's where we get this from. If you guys have a geometric sequence that has a common ratio, you guys can use this formula. A sub n equals a sub 1 r raised to the n minus 1. It always works. Always. Go ahead and ask your question. So how would we write the rule, the nth term for letter A? For this one, you go like this. You would go a sub n equals the first term times the common ratio. What's my common ratio again? Dose. And then I raise it to the n minus 1. But that's not our final answer. Magic has to happen. Why does magic have to happen? Because this base is the same as this base. And if you have 2 bases that are the same, you can multiply them together and do something special with their exponents. What do we get? We get 2 raised to the 1 plus n minus 1, which equals 2 raised to the n. This is our nth term for this sequence. this geometric sequence. Let's try it again. The next one. Actually, you guys try it first, and then I'll do it. So I just give you guys time. Let's do it out now. We have a sub n equals the first term, which is 12, times the common ratio raised to the n minus 1. But we do have some simplifying that we can do. What are you talking about? I could write 4 times 3 for that 12. And now I have two numbers multiplying to each other that have the same base. What exponent does this 3 have? Uno. And so I get 4 times 3 raised to the n power, because we have 1 and negative 1. Those would cancel out. So your a sub n is this one. If you left your answer like this, it is not simplified. Now for the last one. A sub n equals... Now, you have different things you can do here. Now, some of you guys might be like, I don't like these alternating signs. You could just go negative 1 raised to the n, and that'll do away with that. Because that will automatically switch the sign every term. And now you can ignore it if you wanted to. So we have to multiply that times the first term, which is 1/3. And what is the common ratio? Oh yeah, it's 1/3 raised to the n minus 1. Okay, and then, same stuff happens here. We have to add the exponents, so we have negative 1 raised to the n, and then we have 1/3 raised to the n minus 1. Now, no more minus 1, it's just raised to the n. Now, could we instead say that our common ratio is negative 1/3? Could we? Would it work? Let's see. A sub n equals 1/3 times negative 1/3. Oh wait, this would be the first term, right? Negative 1/3. And if we say our common ratio was negative 1/3 raised to the n minus 1, then that means we add the exponents, we get negative 1/3 raised to the n, because the 1 cancels out the negative 1. We got to see if this works. Does it work? Let's see. If I plug in a 2 right there for the second term, do I get positive 1/9? Yeah. If I plug a 3 for the third term, do I get negative 1/27? Yes, I do. So this works. So this is cool, and this is cool. I like both these answers.